Okay, so when you think of an earthquake, you probably think of a sudden, violent shake, right? But what if I told you that some of the biggest movements on our planet happen in complete and utter silence? Today, we are diving deep into the whole spectrum of how our Earth moves, from those catastrophic megaquakes we all fear, to these silent, slow slips that are totally rewriting what we know about seismic risk. So here's how we're going to break it down. We'll start with a really dramatic event, one that sent shockwaves literally across the entire planet. Then, we're going to uncover the hidden, secret movements our Earth is making all the time. And finally, we'll see how understanding both the loud and the quiet is absolutely critical to figuring out the risk we all face.
All right, let's get into it. Our story kicks off in one of the most seismically active places on the planet, the Kuril-Kamchatka subduction zone. It's this incredibly volatile stretch of coastline off of Russia, where the Earth's tectonic plates are locked in this relentless, super slow-motion collision.
And this map right here, this shows you the heart of the action. You can see that massive Pacific plate literally diving, or subducting, underneath a smaller plate. Now it's grinding away at about 79 millimeters a year. That doesn't sound like much, I know, but just try to imagine the insane amount of pressure that builds up, year after year, decade after decade. It's immense. And in the year leading up to the main event, the Earth basically started screaming. It was sending out these really serious warning signs. First, you get a big magnitude 7.2 quake in August of 24. Then, just 9 days before the big one, an even stronger 7.4 hits. And in those final 10 days, the area was rattled by over 50 quakes of magnitude 5.0 or more. You could just feel that the pressure was hitting a breaking point.
And then, it happened. On July 29, 2025, that breaking point was finally reached. All of that stress that had been building up for so long was unleashed in one single catastrophic moment. The result? A staggering magnitude 8.8 megathrust earthquake. This is the kind of quake that happens when one tectonic plate just violently shoves its way under another. And look, this wasn't just a big quake, it was a monster. Truly one of the most powerful tremors recorded anywhere on Earth this century.
And just to give you a sense of the scale here, just look at the company this earthquake keeps. It's right up there with the devastating 2011 Tohoku quake in Japan and another massive one in this exact same region way back in 1952. This thing was absolutely one for the history books, ranking among the 10 biggest ever recorded.
You know, an earthquake this powerful doesn't just shake the ground. When the seafloor lurches upwards with that much violence, it displaces a colossal amount of water, and that kicks off a tsunami that just radiates outward across the entire ocean.
Near the epicenter, the effects were just devastating. On the nearby Kuril Island, the waves reached a maximum height, a run-up, of 19 meters. Let me put that into perspective for you. That is like a 6-story building made of water crashing down on the coast. Just unbelievable.
But the energy from this thing just kept on going. I mean, look at this. Significant waves were measured thousands of kilometers away. We're talking over 1.7 meters in Hawaii and more than a meter in California. The wave's power was felt as far south as the Galapagos and even Chile. It crossed the whole Pacific.
So, the Kamchatka earthquake is this terrifying, textbook example of what scientists call a fast slip event. It's that violent snap that we all think of when we hear the word earthquake. But it also makes you wonder, right? Is this the only way the Earth lets off all that steam?
Well, the answer, which is becoming clearer and clearer to scientists, is a definite no. It turns out releasing all that tectonic stress doesn't always happen in a sudden, destructive snap. Sometimes it happens in a whisper.
Scientists have uncovered this absolutely fascinating phenomenon called a slow slip event, or SSE. So picture two tectonic plates pushing against each other. Instead of getting stuck and then suddenly breaking loose, in an SSE, they just slide past each other, quietly, over days or weeks or even months. And here's the crazy part. They release the same amount of energy as a pretty decent earthquake, but it happens so slowly that we don't feel a single thing.
And this is where it gets really important. These silent movements aren't just some weird, isolated thing. Scientists are finding that these slow slips can actually be linked to the start, the spread, and even the end of major earthquakes. It means a massive amount of energy can be released, almost silently, right under our feet.
And now that we have better technology, we're starting to spot these hidden movements everywhere. For example, in a recent study off the coasts of Peru and Chile,
Another one of these huge subduction zones. Scientists found 24 of these slow slip events that we had no idea were even happening. They often pop up in these transition zones where the tectonic plates are kind of stuck in between being totally locked and just creeping along.
So this completely new understanding of both the silent and the seismic movements really forces us to step back and look at the big picture. I mean, if the ground can move in ways we can't even feel, how in the world do we even begin to figure out our planet's true seismic risk?
Well, that is the exact mission of organizations like the Global Earthquake Model Foundation. It's a nonprofit that pulls together all these public and private partners to build a clear, data-driven picture of earthquake risk pretty much everywhere in the world.
And the way they do it is by building these incredibly detailed risk profiles. This isn't just about drawing lines on a map and saying, hey, an earthquake might happen here. No, they layer in tons and tons of data. We're talking everything from the history of past quakes to what kind of buildings people live in to the potential economic damage to create this really comprehensive model of what's truly at stake.
And this brings us right back to the most critical takeaway from all of this. Slow slips and big earthquakes are not two separate things. As scientists are now showing, they are deeply, deeply connected. A silent slow slip event could actually be loading more stress onto a locked section of a fault, maybe even setting the stage for the next big one. So, what does it all mean? Are we any closer to forecasting the next big one? Honestly, not yet. Predicting the exact time and place of an earthquake is still the holy grail of seismology. But what we're talking about today is a monumental leap forward. By learning to listen to the Earth's whispers, not just its roars, we are getting a clearer picture than we've ever had before. And ultimately, that knowledge, that's our best defense. That's how we build a safer future.